Hey, carnal! Welcome back to La Nueva Sala de Costura. We are looking at big stepper motors on our inexorable march to not doing CNC. I got a secret squirrel project going on here, and I need to drive some big steppers. Now, there's lots of information on the interwebs and on YouTube's about driving little tiny steppers. You can drive these right from an Arduino, maybe not this size, but one size down. But we're talking about NEMA 34 and larger, biggins. Now this is a tiny little stepper for industry, but for a home gamer, this is huge-o. Now, fuck-ups, I see my share. I ain't saying they're all my fault, but generally it is a loose wing nut on the steering wheel what causes the problem. So I'm going to go over the common mistakes that I made so that you don't have to. As many of you know who have begun down the long, windy, and never-ending trail of hobby shop machining, machinery tends to expand like a gas. It fills the area, and I am no different. Of course, I started seeing guys doing spindexing. I totally blame this old Tony for that, but I figured instead of getting a manual machine for the same price, I could go offshore and check out the quality of a rotary axis. Now, this is a stepper driven rotary axis. I bought it and I figured I'd be able just to test it out, proof of concept type deal, just with what was available to me, which was the Arduino and the Adafruit stepper motor driver, well, the motor shield, motor party shield. You guys were wondering what that HPHT is on there for. Well, it's for cooling. You can put a little water on there, some fresh spring clean water, and that evaporates. And that's what cools the chip down. What for overdriving it for driving something like this. See, this runs 3.4 amps peak, and these only drive 2 amps. So I figured it'd be okay just to test. Guess what? Fingered wrong. Then continuing with the theme of mental shortcuts, every time I take a shortcut, it always bites me in the ass. Always, invariably. So I try not to take shortcuts, but it's a judgment call, and sometimes you figure, hey, it'll be fine. It's not fine. It never is. So what I did was I ordered a bunch of these easy, big easy stepper drivers. No, this is just the easy driver. This is that Schmaltz guy that built the Eggbot module for the AxiDraw as well. Obviously a fart smeller. And unfortunately this, same thing, it'll output more power, more voltage, still didn't work. Quite literally, a couple of minuten on the old Gargler, looking up the data sheet for this, would have told me, would have set off alarm bells that maybe I can't drive this with 2 amps and 12 volts. On account of this motor being rated for 70 volts. That's what messed me up, was I didn't even consider the voltage, I just looked at the current. So, mistake the first, and continuously done all over the world by people everywhere. Look at the fucking data sheet. And of course I am human, a vain and petty man. The whole time I'm minimizing the width and breadth of my own stupidity, trying to fabricable, maybe if I add this or that, maybe I can get it to chooch enough just to make some moving images, just as a proof of concept. Forget it. Right off the bat, any project, you have a problem you want to solve, okay? So you have to identify the problem you want to solve, then you have to specify the equipment to solve that problem. You always work backwards. Here's what I want at the very end. How do I get there? You work through the steps. I didn't do that. I jumped to the end and didn't think about how I was going to get there. Now my problem, one of my problems, was I wanted to get reasonably repeatable motion, and I didn't want to have to babysit the fucking thing. So CNC is the way to go. Not that this is CNC because there's no G code involved, so that I'm clinging. I'm clinging to not doing CNC, but this essentially is CNC, and there's 2 ways to do that. There's the fabricable way with the Arduino, and the proper way with the confuser and a G code interpreter and all that. We'll get into it. 2 ways to do this. First way, more skookum, more expensive, more adaptable, so you can change it later on and it's quite a bit easier, but you got to put a lot more gumption in the front end to learn all this friggin' crap. Whereas the way I'm going to do it, it's purpose built, so it has one purpose. It's not that adaptable, way cheaper, however, quite a bit more janky. The thing is, free time, I got a 3-year-old, free time is priceless. So if I don't have to spend a week a dicking around to learn some new software, I'm not going to do it. I'm going to do the easy on the front end because the end goal is suitable for just that one function. I don't need to have CNC. I just want it to be repeatable and do a couple little things. So the first way is to build a computer CNC. The Pro, of course, it's adaptable, it's more robust. Con, it's more expensive. You need drafting software. You got to change it to G-code, there's an interpreter, etc. So here is an unhappy guy using his free time at the Confuser to bone up on the SolidWorks, or alternatively get boned by SolidWorks, and that has to get changed into Linux CNC or Mach 3 or something. You need a dedicated Confuser for that. The Confuser outputs ones and zeros into the CNC controller board. The CNC controller board outputs little pulses into the stepper. I do not have a CNC controller board. I do have a stepper driver. The stepper driver is controlled by is controlled by the CNC board, but it's given power by a big beefy power supply. This is 48 volts. The one I got this hooked up to is 80 volts. Then the stepper driver outputs that 80 volts at however many amps into that stepper motor. Now a stepper motor, the best way I've heard it explained is John from NYC CNC. Actually, just think of it as a magnetic rotary switch. So it pulses a magnet, it clicks. Pulses another magnet, it clicks. And that's essentially all it's doing. It's just clicking around in a circle, and you can control how many clicks it gets. So you can control where the position of that switch is. In this case, it's actually a motor, but that's what it's doing. Now, the other way to do that is with an Arduino, or an Arduino of your flavor. It could be an MSP43, whatever, it doesn't matter. All you need to be able to do is program this, and it needs to be able to output this square wave. So the Pro, it's cheap, it's purpose built, and there's no drafting involved. The Con, it's janky, glitchy, it's purpose built, so you can't do anything else with it unless you reprogram it. And it's janky. If there's any serial communications, any kind of communications with the Confuser while it's live, any kind of janky power supply, anything like that, it craps out. Totally craps out, as we saw in the lapping jig. So you got to be careful with that. The way it works is, here we have a happy-go-lucky guy who's not using much of his spare time because he already knows somewhat the cut and pastry involved in the Arduino IDE, the Arduino programming. Gets on the Confuser uploads that to the MCU. Now you don't need this anymore. You can turf it. All you need is the MCU. It outputs the square wave pulses to the stepper driver. The stepper driver chops up the power supply and goes to the stepper motor. Turns, does whatever you need it to do. Now remember, don't panic. There's nothing new under the sun. Guys have built this before. There might not be that much documentation online, or it might be outdated or just not in a format that you're interested in, but it is there. Someone's built it before. It's all just Lego, partner. You just got to put the right pieces together. Now we can see the Arduino is chooching away. We got those blinking lights in. We have a linear actuator, a slide. We are going to turn on the power supply because this completely isolates the brain box from the rest of the system, because this is 80 volts. Well, 70 volts is turned down. Any kind of electricity, plus minus 10 volts, no big deal. This is rated for 70. I actually have this set at 70, but you can adjust it all the way up to 85. Plus minus 10% is not going to hurt anything. Even on the Arduino, it runs at 5 volts. It'll run at 4.5. It'll run at 5.5. No big deal. More intact. And we've got the enable disabled by that red. Turn it on. There we go. There we go. There. So I've got it programmed just to go back and forth. We'll get into the meat of her right now. We've got our linear slide now working backwards. Here's the stepper motor. It is a 2-pole stepper motor. You don't want anything fancy, 5-pole, etc. Nonsense. Just get easy and dumb. You buy this right off eBay, AliExpress. I'm surprised at how good it actually is. The only thing is, it doesn't have, no thrust on that end. It's relying strictly on the shaft of the motor, so but it will put out a fair bit of force, and it's good just for aligning or just for doing that motion. So 2-phase, that means there's 4 wires here. So we have A positive and A negative phase, and B positive and B negative phase. Then we have the power, 80 volts going in. There's a bunch of dip, let me zoom in on that. So there's a bunch of dip switches here that control how many pulses per rev, and also the maximum amperage that this thing puts out. Here is the brain box side. It's the signal in. So we have a pulse, positive 5 volts from the Arduino, then the ground, and then we have direction if it's going forward or reverse. So we have a positive and then to ground, and then we have an enable, positive and to ground. Now if we drive this enable high, that is we give it 5 volts, turns off. I have on the breadboard right here just 5 volts coming directly from the Arduino going into there on a latching switch. So when I don't put 5 volts to it, it enables it. When I put 5 volts to it, shuts it off. Now we're going to set up the rotary axis. I'm going to get the program just perfect. It'll be a canned routine where it goes forward and reverse in order to make a certain profile, just a nice round profile on the Bridgeport milling machine. Now, trap for young gamers, or you're going to get these and the wires will just be loosey-goosey. They're unmarked. You don't know what to do with them. So what you need to do is take your ohm meter and ohm them out and check to see which wires are connected through that coil. Remember, this is an electromagnet, so some of them will have kilo ohms resistance, mega ohms resistance, and some of them they'll be paired up and they'll have like 1 ohm resistance. So I guess red and yellow. Got red and yellow. Where in kilo ohms they're not connected, so they're separate coils. And we go red and green. Nope, still not. So we know now that green and red go together. And we'll just confirm that. And 1.5 ohms. So red and green go together. Now, it doesn't matter how you stick them into this box here, as long as you're on A positive and A negative. It doesn't matter if you do it this way or this way, as long as they're both on A. And of course, if we were smart, we would take a half a second and mark these so that we don't have to ohm them out again, but you know. This will never ever get disconnected ever again. There we go. Nice and slow. So it goes for a certain amount of steps, stops, waits 5 seconds, goes for another in reverse. I think you can see where I'm going with this. I'll change the program so that there's no variability. It does the same thing every time. Purpose built. This is a stepper motor, so it takes pulses, takes 200 pulses in order to get it to chooch 1 revolution. However, you're going to ask now, and I'll zoom in on this, you're going to ask, what the hell is micro-stepping? And you go on the Gargler and it's obfuscated by reams of data. It doesn't make a sense. All this is doing, and it's instead of getting it a full pulse, 70 volts, 2 amps, it's ramping up. It's giving it 20 volts and 30 volts. It kind of makes it look like the input is more of an AC waveform. And instead of getting a full cog, a full gear tooth on the stepper, you get little bits of a gear tooth. Now the problem is, of course, this is sort of an unknown quantity, so I got to dick around with it. I've got it set a certain way, and I think more than likely it'll probably just chooch a little tiny bit and then stop and then back the other way, which is no good for us, but we are testing. So I'll upload to the board, and it's compiling, etc., etc., and it's uploaded, and it's happy. Dust blinking lights in. A lot slower, that's what I want. And moving 500, 800 steps. And for some reason it's going the same direction. So we either, like I say, janky, we lost an input, or I ruined the program. It's a process. There's a lot of tinkering involved. You know, there was no prototype before this video went up. It ain't the old Milwaukee workshop here where things get built, get the glitches out of it, and then you show the end product. Ah, beautiful. This is real, man. So I marked the output just to see how many steps it takes to get this to rotate once, and that's 800 steps. However, there's a gear reduction. Now we could count the cuts in the cog belt wheel, the pulley, and calculate from there, or we could just get on the gargler and see what the supplier says the ratio is. According to I will turn that off. According to the data sheet, the ratio is 6:1, so we're going to try that. 800 times 6 is 4,800, which means that one step here is an angle is, yeah, pretty much half a bee's dick. So 4,800, and we'll mark it and see if that gives us a full rotation. Perfect. Dead nuts on the money. 4,800 in the count there gives us one full rotation of the chuck. So I want square stock in the chuck, and I want it to have a nice rounded off, one side totally rounded off. That means I got to put 2,400 in that count, and that'll give us 2,400 steps, and that will give us 360, 180 degrees. So this is a program for taking square stock or any stock and doing a half round. So here we set out our constants and our variables. One variable, an integer variable, is going to be count. We set that at 0. Then the pulse set, that's how many steps the stepper is going to do. 2,400. The direction, that's a constant, so that's the pin that determines the direction. That's pin 8 on the Arduino. Pulse pin is pin 9 on the Arduino. And there's a constant integer, the sensor value, 4,000. So that is, what is that? That's the speed. That's going to be the speed. And it was on a potentiometer. I changed that, but I didn't change the name of it. So it's all through here. And we just set that at 4,000. That's pretty slow. Then we go into the void setup. It runs through this program once. It just tells it the pin mode, direction pin is an output, and the pin mode, the pulse pin, is an output. Then we go through the void loop. This is going to loop time and time again. We set the count to 0. It's already set on the first time around, but you'll see. Now, while this count value is less than the pulse setting, which is 2,400, it's going to go through this while loop continuously. So it's going to say go forward on the direction pin. It's going to drive that high. Then it's going to pulse high on the pulse pin. That's going to delay for 4,000 microseconds. 4 milliseconds it's going to delay. So it's going to be on for 4 milliseconds, and it's going to turn off for 4 milliseconds. It's going to update the count. It's going to add 1 to that value of count. So now we have 1 in there. We're in the while loop still. Is 1 smaller than the pulse set? It's 2,400. Absolutely it's smaller. So it continues going on there until it reaches 2,400. Then it pops out, it breaks out of that while loop. Not quite what you'd call an industrial setup. That's okay. We got the solution. Let's make sure the chips don't go. Well, the chips are going to fall where they may. There. Perfect. I got the confuser in the shop now, and I just reprogrammed that so it goes a little bit faster. It was at 4,000 microseconds on the pulse on off. Now it's at 1,000. We'll have a peek and then see if it's sketchy or not. Well, guaranteed it's going to be sketchy, but see if it's too sketchy. Whoa! Good thing I wasn't using my finger. The patron saint of bumblefuckery, well, terrible movies has taught us anything. It's what you want is a medium pace. Fair bit of chatter there, not perfect, but yeah, it's good enough for the girls I go out with. Isn't that interesting? This thing didn't glitch out, not once. Now, here's the key. It wasn't doing any comms. It wasn't talking to a confuser. It wasn't doing some sort of weird protocol that sends ones and zeros to a shield that turns the motor on like we had with the Adafruit shield, motor shield. It was on the I2C bus. So anytime these things got to communicate, it's like they got to dial up via Skype. It's just brutal. They glitch out and shit happens. So I think as long as the power's fairly clean and it's not communicating, just turning a pin on or off, I think it's pretty solid. And so, in conclusion, what I find is I like to watch videos and just get a feel for what's going on, and then I like a bullet point format written instruction that reiterates what you need to do in order to get certain things to choose. So that's what I'm going to do, is bullet form here, and I'll write down in the doobly-doo along with the program what to do. So first thing, you got to select the size of stepper you need for the amount of torque you need. Maybe you're buying an off-the-shelf slider. You get the data sheet for the stepper. That will tell you how many volts, how many amps. That tells you what size micro stepper driver to buy, or little motor shield from Adafruit or Spork Fun, whatever. That also tells you what power supply to buy. So this one, right, 48 volts. Then what you do is you connect up the Arduino into these inputs. All the grounds go to the Arduino ground. All the inputs, there'll be 3 inputs, go to the positive. That's it. Remember, the enable pin, when it is high, when it has 5 volts on it, shuts everything down. Then you select, for the stepper that you have, you select the amperage that this thing will output, and you also select how many steps you want for each rotation of the stepper. Now, micro stepping, you would think, okay, I want 50,000. It gives you less torque. So it's a trade-off. You want resolution, but you need some oomph. So the fewer steps, the better. The good trade-off is 800 for that NEMA 34 that I had. Okay, and then you go ahead and ohm out your stepper, so you know which electromagnet is which. Essentially, you'll ohm these out, and they'll be like 1 ohm, and you know these are a pair and these are a pair. You mark them, unless you're me, and then you go ahead and connect them up, and you connect this guy into your power supply, and you upload the program. Bob's your auntie. That's all there is to it, man. No big deal. Okay, thanks for watching. If you got questions, you look at this video, you got questions. If I don't answer your questions, some helpful soul in the comments down below me will. So, thanks a lot for watching. Hey, keep your dick in a vice.